Welcome to the ZTNA lesson. Click Next to get started. After completing this lesson, you will be able to achieve these objectives. Describe ZTNA. Explain how ZTNA works. What is ZTNA? ZTNA establishes a secure session between an end entity and a network, while ensuring granular control over access to resources and exercising zero trust, regardless of the location of either the end entity or the network. Part of the zero trust principle is the practice of least privilege access. This means that users are only granted access to the resources necessary to fulfill their job requirements, and no more. As a network security concept, zero trust operates under the premise that no user or device inside or outside the network should be trusted, unless their identification and security status have been thoroughly checked. Zero trust operates on the assumption that threats, both outside and inside the network, are omnipresent. Zero trust also assumes that every attempt to access a network or an application is a threat. So regardless of whether the end entity is remote or on premises, the connecting computing device automatically establishes an encrypted session with the network. Specifically, this connection takes place between a ZTNA client at the end entity and the ZTNA access proxy, which could be a firewall. The proxy point hides the locations of requested applications from the outside. The proxy directs the client's request to the application, which could be on-site or in the cloud, only if the user meets access requirements. Other ZTNA components are authentication and security. Because the user is identified through authentication against an on-premises backend server or an identity as a service, IDaaS, policy can be applied based on the user roles. Also, the ZTNA policy server enforces policy to control access, specifically to applications. For example, access could, in part, be based on geolocation. So if the remote device is connecting from an unexpected point in the world, access to an application could be denied or privileges reduced. Likewise, if a device fails a security sanity check, the user could be denied access. Security is composed of firewalls and the ZTNA access proxy, which control access and provide security to application resources. Unlike IPsec VPN, but similar to SSL VPN, ZTNA is vendor-specific. This means that each vendor can implement ZTNA in a way that best suits their specific requirements. The diagram on this slide is the Fortinet ZTNA solution. The Fortinet ZTNA client is FortiClient. Also in this diagram, FortiClient Endpoint Management Server, EMS, acts as the ZTNA policy server. When an endpoint device with FortiClient attempts to connect to the network for the first time, it is directed to FortiClient EMS to register. During the registration process, FortiClient provides the server with information about the device, the user, and the security posture of the device. This information is written to tags and shared with the firewall, FortiGate. Based on the information in the tags, the device can be grouped and certain rules can be applied. The rules act as instructions for FortiGate. FortiGate applies the rules to the device each time it connects to the network. An example of a rule could be that a device with Windows 10 plus antivirus software is allowed access, but a device with Windows 10 and no antivirus software is denied access. At the end of the registration process, FortiClient EMS generates a digital certificate for the device and sends the certificate to the device and shares with FortiGate. From this point onward, the device submits the certificate to FortiGate each time it needs to identify itself. FortiClient is in continuous communication with FortiClient EMS. If the endpoint information changes, the server updates the client tags and resynchronizes with FortiGate. The ongoing communication between these components is called network telemetry, and it provides agile and dynamic responses to enhance network security. How does Fortinet ZTNA work? When the endpoint connects to the ZTNA access proxy, FortiGate challenges the endpoint for device identification. The endpoint sends the device certificate to FortiGate, proving the device identity. Then FortiGate applies the associated tags and rules and either rejects the request or allows the device to proceed. FortiGate challenges the endpoint for user authentication. The endpoint prompts the user for their credentials and delivers the credentials to the access proxy. In turn, the access proxy sends the user credentials to the backend for authentication. The authenticating server could be an Active Directory, an LDAP directory, a database, or IDaaS. The ZTNA access proxy retrieves the user's identity along with role information. FortiGate uses the role information to help determine if the user has permission to access the requested network application. Finally, assuming that the device and user have been identified, and the device tags and rules plus the user's roles allow access to the resource, an encrypted session is initiated between the ZTNA client and the ZTNA access proxy, when the user gains access to the application. You've completed the lesson. You can now achieve these objectives. Describe ZTNA. Explain how ZTNA works.